Hello guys and welcome to the channel. Today we're going to continue the introduction to limits part 3, and that is the last part for this topic. Okay, I made 3 other exercises that will help us to gain our skills in solving those type of problems. Okay, let's begin. We have the exercise 1. The limit when x goes to 0 of x plus sine of x over x times the cosine of x. To solve this exercise, we'll look again at the important limits. In this case, we have again the limit when x goes to 0 of sine of x over x is equal to 1. Then we multiply the sine of x by x and divide it by x in order to transform it in this form. We have the limit when x goes to 0 of x plus the sine of x over x times x over x times the cosine of x. When the limit when x goes to 0 of sine of x over x is equal to 1, then we have the x plus x in the numerator, and the limit when x goes to 0 of 2x over x times the cosine of x. And x's cancels out, and we end up with the limit when x goes to 0 of 2 over cosine of x is equal to 2, because if we put the value of x equal to 0 and the cosine, we have that the cosine of 0 is equal to 1. Okay, let's move on with the exercise 2. We have the limit when x goes to 0 of 2 arcsine of x over 3x. In this case, the table of important limits will help us again. But first, we have to make a substitution with the parameter t. If we do, we have the arcsine of x is equal to t. And if we do the sine of the two sides, we'll get the value of x depending on t, where the x is equal to sine of t. And when x goes to 0, then the t goes to 0. Now, put those values now in the limit, and we end up with the limit when t goes to 0 of 2t over 3 times sine of t. We'll do the same thing as we did in the previous example to divide and multiply by t the sine term. And we have the limit when t goes to 0 of 2t over 3 times sine of t over t times t. And that is equal to the limit when t goes to 0 of 2t over 3t. T cancels out and is equal to 2 over 3. Okay, now exercise 3. We have the limit when x goes to 0 of 2 minus 2 cosine of x over x to the third power. When we see that our limit has any factoring, it is good to do it from the beginning. So we have to factor the 2 here. We'll have that the limit when x goes to 0 of 2 times 1 minus the cosine of x over, I've written the x to the third power as x squared times x. Because from the table of important limits, we'll see that the limit when x goes to 0 of 1 minus the cosine of x over x squared is equal to 1 over 2. Then we have this form here, and the limit when x goes to 0 is 2 over x times 1 over 2. 2 cancels out, and the limit when x goes to 0 of 1 over x is equal to infinity, because if we put the value of x is equal to 0 here, we have the constant over 0, and that is infinity. Okay, I've written 8 most important limits that are called the table of important limits, right there, without which we cannot solve most of the limits problem. First one is limit when x goes to 0 of sine of x over x, and that is goes to 1. All the limits are when x goes to 0. We have the tangent of x over x is equal to 1. The limit again with 1 minus cosine of x over x squared is equal to 1 over 2. The limit when x goes to 0 of e to the x minus 1 over x is equal to 1. The limit when x goes to 0 of e to the x power minus 1 over x is equal to the natural log of a. The limit when x goes to 0 of the logarithm with the base a of 1 plus x over x is equal to 1 over the natural log of a. The limit when x goes to 0 of 1 plus 1 over x all to the power x is equal to the Euler number e. And the limit when x goes to 0 of 1 plus x all to the n1 power minus 1 over x, this will end up with the n1. Thank you so much, guys. We'll see in the next video. We'll continue with continuity and differentiability.